Fuel injectors are found in some form on every new production car sold today in the United States. They have become an essential part of meeting stricter emission standards set by the EPA. Fuel injectors take pressurized fuel and release it as a stream of fuel into the intake. Fuel injection began to replace carburetors in the 1980s, as manufacturers began to cut down on their tailpipe emissions. The earliest forms used an injector in the throttle body to get fuel to the engine. While they utilized a fuel injector, they shared many similarities with carburetors. These systems were then replaced by port fuel injection. Port injection systems spray fuel directly into the intake runner, where it can be pulled into the cylinder with the intake air. Injectors receive a signal from the control module to either add or reduce fuel by adjusting injection length and timing. The fuel pressure can range anywhere from 40 to 70 psi and is supplied by an in-tank electronic fuel pump. Recently, direct injection has become more prevalent. These systems are similar to diesel engines in which fuel is sprayed at very high pressures directly into the cylinder. With direct injection, much higher fuel pressures are needed to overcome compression pressures and to better atomize the fuel. This type of injector can use pressures as high as 5,000 psi to spray a cloud of fuel into the cylinder, which consists of millions of tiny droplets. These pressures are possible thanks to an electronic in-tank fuel pump which feeds a mechanical pump. The mechanical pump then raises the pressure to necessary levels. On the whiteboard is a solenoid type fuel injector. Almost all modern fuel injectors work on the same principles as this. In this type, fuel is supplied through the top by a fuel rail. The injector is sealed to the rail by this O-ring. On the bottom of the injector is sealed to the manifold by this O-ring. Fuel fills the injector but cannot be sprayed because the pintle, found in green, is sealed to its seat. When current is supplied by the control module, this coil creates a magnetic field which pulls the pintle upward. When the pintle is pulled upward, fuel can be sprayed into the manifold until the current ends. When the current ends, the magnetic field collapses, which moves the pintle back downward by the return spring, and fuel spray ends. There are many ways to diagnose fuel injectors. An injector can fail electrically due to a shorted coil or high resistance. Both can be diagnosed using a multimeter to test resistance. This can be done in the car as long as the injector is accessible. Injectors can also be clogged with debris or stuck open or closed. To diagnose a stuck injector, a mechanic's stethoscope can be used to listen for the movement of the pintle. You should be able to hear a ticking sound as the pintle moves. When no noise is heard, the injector is likely stuck and causing a misfire. The most thorough test is to test the injector in a flow bench. A flow bench can run dyed cleaner to test for spray pattern, flow, and leakage. This flow bench can simulate an injector cycle at various RPMs and measure total output of each injector. While flow benches are a great test, they also require you to remove the injectors, and the equipment is also very expensive. Current must end the coil